We all done reading?
This.
You have electrical, no, we can't.
It's gonna be our third time reading this.
Okay, very good, guys. Now your attention, everyone.
Third time reading
Got a
this.
zero.
Second time reading.
Got a zero. Okay. Now, first of all, what is the vocabulary word on this page? Yes. Right, electromagnet. A device in which current produces magnetism is called electromagnet. Guys. So, now on the bottom right-hand side of the page, in the first box, write the cause of the action. You write the cause of the action in the second box. Then figure out what the effect can cause and fill in the third box. This is a little confusing, but if you guys understand it, you guys can go right ahead. Any questions, we can do it together. This is a little funny. What we're going to do is put in the first box, like for instance in the middle you have electric current flows through a wire. So what would you do, what would go in the first box and the last box if you have electricity in the middle? You want to do it together, or do you guys? Okay. So who wants to help? Raise your hands. Who wants to say one first? What would they put in the first box? Yes. Anybody here? Who wants to put something in the first box? If you have electricity in the center box, say we put in the first box the cause of the action, and then in the second box. And figure out what the effect can cause and fill in the third box. Yes. Right. Sure, you can do that. If you say in the first box you want to put phone, and then the electric flows through it, and then what's the effect? Like what happens with the phone? Like what do? You plug it in, right? Like you're saying to charge it? Okay. So if you're going to put the phone in the first box, you plug it in, electricity flows through it, and what's the effect? What happens? It's charged, right. Did everyone see that? So in the first box we're going to put phone, like a cell phone, and in the middle box we have electrical current flowing through it, and then the effect in the last box is that the phone is charged. Okay? So we're doing a cause and effect. Yes. Sure, the first box you're going to put phone, like a cell phone. And then in the middle box we already have electricity. And the last box we're going to put what happens when you plug the phone in. So in the last box, the phone is charged. It's charging, or it's charged when it's all done charging. Now, who else can volunteer another one for the first box? We're only going to do a couple of these. Yes. You can do a computer. So if you put computer in the first box, everybody put computer in the first box. Okay. So write computer in the first box. One sec. Okay, and then we have electricity flowing through the computer, through the wires, and then what happens in the last box? Yes.
The computer's powered.
Right, it turns on, right? Right, so you can word it any way you like. Computer comes on, it gets turned on, it gets powered, it lights up. See? You can do one, yes. A lamp, right, that's a good one. So you put lamp in the first box. Everybody put lamp, this will be the last one, and then we'll move on. Well, we can do it on if you'd like, hold on. Lamp in the first box, and then if you have power in the middle box, electricity, what happens in the last box? Yes. Right, the light lights up. Is everybody getting a better handle on how this works? Yes. Do you have one?
An iPad.
Okay, an iPad. It's kind of like a phone, but you want to say, Okay, say video game, that's a new one. So we'll put video game in the first box. And then when the power flows through it, what happens in the last box? Right, it works, it comes on, exactly. You see how important electricity is? Imagine if we didn't have the electricity, like on the first pages with the old-fashioned appliances. Okay, now if we go to the next page, and you guys can read at your tables one more time. I don't think we need to do the rock, paper, scissors. Why don't you read this time? Who didn't read it? If she didn't read it,
Okay, go first.
did you read it all yet?
I'll take a turn.
Why don't you take turns? You don't really want to read the first page because there's not much reading. If she wants to read it, put that in.
Conserving electricity is good.
Reading guys? Section to read.
That's just how you say that. A device electricity generating station, also known as energy station, aids one or smaller atoms to produce the electricity used. Did you just say electric station? Yeah, you did. You said electric station. Water or wind generate energy stations convert solar energy to electricity. Resources were never they are called renewable resources.
Am I on it right?
Windmills have been used to grind grain or pump water. Today, wind turbines generate electricity. Say what?
Okay, it looks like everyone is done. Now, what is one of our vocabulary words on this page? Guys, what's our vocabulary word on this page? Generator. You made a generator, a device that converts kinetic energy to electrical. Okay, now, I have a couple other. What is hydroelectric energy? Can anyone tell me? Raise their hand. Yes. Right. Well, hydroelectric energy is made from what? Water, right. Now, another one is solar energy. Tell me what solar energy is. Yes.
It's energy made by the sun's rays.
Right, exactly. Guys, pay attention to this. Okay. That's very good. Now, on this page, we have a math problem.
I'm good at math.
Sam's electric bill was $200 for the month of June. The air conditioner accounts for half of the bill, and the water heater accounts for 1/5 of the bill. How much did it cost to run each appliance in June? Yes. $340. The electric bill was only $200. So if it was $240, you have to do your math to figure out. Right. Well, the electric bill was only $200 for the month of June. The air conditioner accounts for half the bill, and the water heater accounts for 1/5 of the bill. So can you guys work out that problem, and then we'll go over it at the end.
Okay, now we know what it is. I don't. I do.
You did it right. You did your math is correct. But you have to figure out the amount of $200. We were in a math problem. We working out the math problem?
Yeah, I did it.
Okay.
Wait.
How you guys doing on the math problem?
I'm done.
Because the bill is $200, so 200 is 10 cents. So you think that's 10 cents minus 7 cents. And there's 1/5 is 2 cents. And if you add those together, it's 7 cents.
I feel like we need to get 20 as our denominator or something like that. I just have a body.
What was the 200?
So you can see we're already working on these problems.
Yeah, 200.
Oh, I think I figured it out. See, this is I know it's Well, wait. So, like, you know how it's like 1/10, 2/10, 3/10? Like 3/10 would be $60 because we're the number's 200. So we're
Okay.
7
Let's see if we can do this math problem together. Okay? If we have this electric bill is $200, and the air conditioner accounts for half of the bill, how much would half of the bill be?
150.
Right. 100. $100. So that's half the problem fixed.
I did 100, yeah.
So if we have,
Stop talking.
guys, if we have $200 and we take 1/5 of the bill, how do we do that problem? Yes.
Divide 200 by 5.
Exactly. And what did you get? 40. So that means that the water heater costs how much to run? How much was it? $40. Okay. You guys see? That's a good job. You guys see how that works?
Yeah, but it's
It's 1/5 of the bill, so we divided 200 by 5 to get 40. So it's $40. Right? No, he was right. 40 is the answer, plus the other bill was 100. So your electric bill is really going to be $200 for the whole electric bill. Those two appliances cost $140 to run. Now, me read the summary to you guys real quick, so we summarize the chapter, okay? And then we'll do our post-test, and then the last thing we'll do is our experiment. Electrical appliances use electrical energy to do work and perform useful tasks. Some of these appliances, such as a flashlight or MP3 player, get electricity from batteries. Others must be plugged into a wall socket. Electrical appliances convert electrical energy into other forms of energy, such as thermal energy, sound energy, and light energy. Many appliances, such as washing machines and fans, contain an electric motor, which converts electricity into an energy of motion. An electric current may also be used to make an electromagnet. Generators and energy stations produce electric current which travels through wires to homes, schools, and businesses. It's important to conserve electricity because of some of the resources energy stations will eventually run out. What are ways that you guys think we could conserve energy at home? Raise your hands. Yes.
Turn off appliances when you're not using them.
Right, exactly. Yes.
Use less electricity.
Okay, yes. Yes. Yep. Right, exactly. Yes.
Put off the TV.
Right. Yes.
When you're done with your video gaming, you should turn off your thingy.
That's right. Turn off the video game. How about this table? Volunteer a way to conserve. How do you think we conserve energy?
When you don't use your phone, you shut off the whole.
Okay, and that way you wouldn't have to charge it as much, right? Yes. Yes?
When you're about to leave your room, you have to turn off everything.
Right. Your lights and radio, everything. Yes.
When you're not using your phone, you're about to get out of the house.
That's a great idea. Right. People don't think to do that. Right now, mine at home is plugged in. I should have unplugged it when I left. You're right. Yes.
When you go like and leave the house, you turn off all the lights and
Right. Exactly. How about this table? What can you guys volunteer with? Yes.
When you leave a room, don't leave your light up.
Right. You had your hand up too.
So if you have like your phone and you click all the apps, because you still have a whole bunch of apps open, they'll just waste on that.
You're right. And then you have to charge it more. Exactly. Yeah, it's really important, guys. That's probably one of the most important things besides learning about energy is how to save energy. That's where all the economical cars come in. We plug in the cars not to save gas, to use electricity, but we save gas at least. We try to save our fossil fuels that we're wasting a lot of different ways these days. Okay, let me pass out the post-test.